When we make a working drawing for the company that's going to cut gears for us, we include a data table that tells them, here's what size to cut this and that feature. Here's how big the addendum is and the dedendum and so on and so forth. So let us spend just a minute here looking at what these terms refer to. This picture here is a segment out of a spur gear. And slow down here and just take a moment to study what we see here. Going through the sort of middle of the teeth, you'll see that pitch circle. And you remember that the pitch circle is where the gears touch each other when they mesh. And everything is based off that pitch circle. Then, from the pitch circle outward, you add some. That distance is called the addendum. And from the pitch circle downward, you deduct some. That's called the dedendum. Those are Latin words, and you can see how addendum is related to our word add, and dedendum is related to our word deduct. So that's the addendum distance from the pitch circle to the outside of the tooth. And then the entire depth of the tooth, the addendum plus the dedendum, is called the whole depth. Down here at the bottom of the tooth, that's the root diameter, and out here at the outside of the tooth is the outside diameter. Now, let's just work our way through methodically. The face width is how thick that gear blank was when you cut a slice off of the round stuff. When you're making the gear, how thick is that slice of metal? That's the face width. Pitch is a word that we run into in all kinds of settings. It's a word that means the spacing from one place to another. In a gear, it means from one point on a tooth to the same point on the next tooth. And this is called the circular pitch because it goes around the pitch circle. Now let's think about the thickness of the tooth. If you measure on the pitch circle, that's a circular arc, that circular thickness is the thickness of the tooth around the pitch circle. You could also measure the thickness of the tooth in a straight line from one point to another. That's called the chordal thickness. And here on this left-hand tooth, you see a line that is the chord. There's the chordal addendum. So let's go look at the idea about circular and chordal by looking at this page out of the beginning of Machinery's Handbook, where they're giving us words and formulas for geometry stuff. In this page, they're looking at parts of a circle. So a part of the outside of a circle is a circular arc. If you cut a straight line across that segment, that's called the chord. So let me back up. When we were looking at the straight line thickness across here, we called that the chordal thickness. When we looked at the thickness along this arc, we called that the circular thickness. Circular and chordal. Here is a picture where I photoshopped it out, and we can see just the chordal dimensions. Usually in your data table, your gear company wants the circular thickness rather than the chordal, but I just point this out to you. Here are the circular dimensions. These are the ones that we typically include in a data table. Addendum and dedendum, or maybe addendum and whole depth. Circular thickness, pitch diameter. I put in 2 pages out of the ASME gear standard just so that you'll have the source document. This is so old, gears don't change much, and this is so old that it still uses the old ANSI standard number. So here are some words about what these parts of the gear are, and more words defining what the parts of the gear are. This is out of the gear standard itself. Now, this chart is out of our book, and we will look at it again in our next set of slides when we start drawing our spur gear. This chart lets you figure out, if you know something, like maybe you know the diametral pitch, can you figure out the addendum? And so here we see, here's the diametral pitch. P stands for pitch. P stands for diametral pitch. So if we look at the top line, he says to figure out the addendum, you would do 1 divided by diametral pitch, for example. And he gives you formulas for figuring out all the other stuff should you need it. This is a handy table to have should you need it. Here is the same set of formulas, but out of the Machinery's Handbook. I thought you might just like to have the Machinery's Handbook version in addition to our textbook version, and you can choose whichever flavor you like looking at. Personally, I actually like looking at this one. I can't tell you why, but you might like this one. Now, we'll stop here and we'll start a new set of slides to talk about how to make a